we're doing a lesson on iteration. And iteration essentially is just doing the same instruction over and over and over and over again until you get one answer. And if you do it again, you just keep getting the same answer. So let's start with something nice, something easy, right? All I want to do is like how to get from one number to the next. Okay. So if you think for some stupid reason you times it by 2, then add 1, it's got to be the same for the next term and next term and next term. So work your way through it. Tell me how to get from one term to the next. Okay. A lot of them quite easy. It's your answers, +2, +3. The only thing is for F, you might not have said times 1.5. You might have said times 0.5, then add the original. And a similar thing you could do with G as well. Okay, right. So we need a bit of notation to be sorted out. Now let's have a sequence above. Okay, now x5. Now what this actually means is actually what is the fifth value in the sequence. So 1, 2, 3, 4, 5. x5 is 11. Okay, and x8 is actually going to be the 8th term in the sequence. So 1, 2, 3, 4, 5, 6, 7, 8, which is 17. And normally we would think the first one is x1. Okay, so let's say xn is 11. Okay, what is xn plus 1? Now you could solve this really and know that n is like 1, 2, 3, 4, 5. Or we could just know if xn is 11, xn plus 1 must be the next term along, yeah, which is 13. And conversely, xn minus 1 must be the term before it, okay, which would be 9. It's just getting used to like the terminology, okay. And it's just two things we need to notice. The majority of cases, x1 is your first stage, but sometimes it can be like x0 is your first term. So just try not to be aware. It will state in the question, so don't worry. Right. So let's talk about this. So how do I get from one term to the next? Now we need to write this like algebraically, really. So if I wanted to do something to represent the next term, I'd use the x, and then I'll put n plus 1. So that's my next term. So to get to my next term, what I need to do my current term, which I'm going to use xn, and then we're plus 2. Okay, so that's saying I've got my current term, a plus 2 to get to my next term. And for b, I want to use my current term, I'm going to minus 11, and that's going to be my next term, okay, which is n plus 1. Put in brackets. Okay, this one down here, I've got my current term, which is xn, and I'm multiplying it by 2, and that's going to be my next term. Okay, and this one here, I've got my current term. I'm going to times it by 2, and I'm going to minus 2, and that's going to be my next term, which is like x n plus 1. The only thing you need to be aware of, go back to the first one, sometimes it might be written in a slightly different format. So it might be to get your current term, you use your previous term, and then you add 2. But essentially these two are identical. Okay, the first one and the second one. Okay, so let's do this one here. Okay, so generate the first 5 terms of this sequence. Okay, I know this one here says my current term plus 5 is my next term, so I've got to start with 4. So my first one's going to be 4, and then I'll do 4 plus 5, which is 9. My next term. Do it again for xn. I use 9. I'll do 9 plus 5, which is 14. And then for xn, I use 14 for the next one, and 14 plus 5 is 19. And this is how I do my sequences. This one here. Work out the next 4 terms. So let's start with 1, and it'll always give you the starting point. So it's going to be 1. Then I'm going to have to do 1 times 3, which is 3. And then I'm going to have to times that by 3, okay, which gives me 9. And I'm going to times that by 3, which then gives me 27. Should be all nice. Nothing too complicated here. It's just terminologies. Give you a sec to do this. Okay, so I'll start with 3, as it says in the question. I'm going to have to times it by 5, and then plus 11. 3 times 5 plus 11. I've got 26. Then I'm going to have to put 26 in place for 5. So times by 5 plus 11, which I've got 141. And I have to times that by 5 plus 11, which is 716. Okay. Now this one here, start with 3. It's going to be 3. My next term is actually just going to be 3 again. It's going to be 3, and it's going to be 3, and it's going to go on forever. Yep. Right, so this is what we do here. Generate the first 4 terms of each sequence. You've got easy, medium, hard. Okay. In every case, start with 10. Yeah, so x1 equals 10. And go and do it. I just want everyone to make sure you do number 4, because 4 is important. Okay, here's your answers. Okay, the big ones, the ones at the bottom get like really big. Now the question I want to ask you is, let's say I didn't ask for the first 4 terms of this sequence. What about if I wanted like the billionth term, or in essence the infinity term? Okay, what are my options that I can get? Now the majority of these I'll get a really big number, because if you look 1, it just keeps going higher and higher and higher. Yeah, 9 gets ridiculously high really quick. So I could get a really big number, which I'm going to call infinity. My other option is, let's say the sequence wasn't getting really big. Let's say it was getting really low. Yeah, so let's say it was going -10, -100, -1000. I'd actually get to minus infinity. And that's a bit of a complicated concept for me just to throw at you. But in essence, you don't care about all of these. There is a third time. And this third one, you'll actually get smaller, or you'll actually get closer to a number. And this one I want everyone to do 4. Because if you look at 4, 4 is going to actually tend to a number. And if we keep going to 4, it's going to give you an answer. Okay, and this is iteration. Okay? So this is what I want you to do. I want you to do the sequence of 2x minus 2. So I get a number. Yeah, so I want you to do it with 1, 2, and 3. So start with 1, times it by 2 minus 2, and do it over and over and over and over again. Now your calculator can help you out. Okay? Your calculator is really good. It's really smart at doing this. If I wanted to start with 1, I'll put 1 equals. Do it with me. So 1 equals. You've told your calculator to store 1 in its memory. Okay? And every time you press answer now, it will bring that answer back. So I'm going to put 2 times my answer minus 2. If I press equals once, I get 0. Press equals again, I get minus 2. Press equals again, I get minus 6. And if you press equals quite a lot of times, you'll notice that this number gets lower and lower and lower and lower and lower. If you do it enough times, it'll break your calculator. Just notice that's going to like minus infinity. That doesn't help me out. Let's now do it with 2. So 2 and equals. So you're telling your calculator to start with 2. And the rest you type it in the same. So 2 times your answer minus 2. I've got 2. And I'm going to press it again. I've got 2. In fact, if I press equals loads and loads of times, I get the answer 2. Okay, which is interesting. Now let's do it for 3. 3 equals. And I'm going to have to do the same thing again. 2 times answer minus 2. I've got 4, 6, 10, 18. If I keep pressing equals, I'm up to 16,386. That's just going to be positive infinity. But there I sort of got a little solution, which is very helpful for me. Okay, well, there you go. Right, now I want you to do this. Okay, I've got a sequence which is x squared minus 2. So what I'm going to do is get a value. In the first case, I'm going to do minus 3. I'm going to square it. I'm going to minus 2. Get my answer. I'm going to square it and minus 2. Go over and over. Do it for each of these numbers and see which ones actually get to a value and which ones don't. Give some time to do this. If you need a bit of structure, here's your instructions. Minus 2 and equals to store it in your calculator. Then do answer x squared minus 2 and equals, and just keep pressing equals loads of times. Now what you should notice is that these are my answers here. So my first one, this one here gets really big, yeah? So this is big, it doesn't help me. And actually when I do 3 again, it also makes it really big. But I've got values here that sometimes they tend to. So it either tends to 2 or it tends to minus 1. Okay. These are essentially my solutions to the first equation. And it's just, this is how iteration works. Okay. Now let's do this one here. I want you to solve it using iteration. So I'm going to start with 1. Press equals. Now, in this one here, really what I'm doing is I'm doing xn plus 1, okay, which is xn plus 1. So I'm saying if I do 1 plus 1, square root it, it's going to give me my next term. Keep going, see what answer you get. Okay. If I keep going, I've got 1.611, and I think that's sort of what it tends to. Yeah, hope you got it right. Let's do another one. But your questions sort of need to start at the start. So here, this is your original equation, and you're normally guided. You normally said, this is my first equation. Show how I can get to that one there, and because it's loads of different ways. And what we want 1x on its own. Now, if we look at this, what I'm going to do is I'm going to plus x and then plus 1 to both sides. So I've got x plus 1 equals x squared. I'm going to square root both sides. Now I've got x plus 1 square rooted equals x. That's normally always your first choice. Now if I wanted to solve this by iteration, my solution is actually the 1.61 answer here, right in the bottom right. And that's how we can solve by iteration. It will only give you one answer, and this one here should give you two. Okay, now we're going to be asked to solve this equation at the top. Okay, again, we're always guided. First thing you've got to do is go make it like this, so it looks like an iteration formula. Now what I'm going to do is I'm going to plus 5x plus 5x, which gives me 5x equals x squared minus 2. Plus 2 plus 2. So I've got 5x plus 2 equals x squared. I'm going to square root and square root, which actually gives me the equation there. If you put the left-hand side and the right-hand side. It's going to ask me to solve. It's always going to give me the first term, because if you don't get given the first term, that's how you get your other answers. Okay. So in my calculator, I'm going to put 5. And I'm going to put equals. Yeah. So I've told my calculator my first number is 5. And I'm going to have to type this in. It gets a bit complicated. I use the square root button. Yeah. Then I'll do 5 times my answer. And your answer can be suited as x and plus 2. And then all I really need to do is just continuously press equals over and over again until we get an answer. So I've got 5, so 5 equals, and then the square root of 5 times my answer plus 2. So I've got 3 root 3 for my first one. 1 equals 3 root 3. And then I've got 5.28 for x2. For x3, I've got 5.33. And I've got 5.35, and 5.36, 5.36, and then you reckon the answer is 5.36. And remember, it is rounded, so if you put it back into the original equation, you shouldn't get a 0, but you should get rough. Okay, so find an approximate solution to the equation 0 equals x squared minus 3x minus 52 decimal places. It's telling you you're going to start with 100, okay, and we need to make this look like the equation of square root of 3x plus 15. Okay, so let's see how we can do this. I'm going to plus 3x both sides. This means 3x equals x squared minus 50. I'm going to plus 50 to both sides. Give 3x plus 50 equals x squared. I'm going to square root, which gives me the answer actually. 3x plus 50 equals x. Good, that's what I wanted. So then let's do the iterative. So I'm typing in my calculator 100 equals, and I'm going to do the square root of 3 times the answer plus 50. So my first one, so I'm going to put x1. I've got 5 root 14. Then 10.301. 8.994, 8.77, 8.73, so I'll run out of spaces, so I'll do it to the right. 8.72, 8.72, 8.72, and I'm going to say my answer now is 8.72. Okay, kids? Right, here's some questions. If you want the harder versions, that doesn't actually give you the guidance. But I'll be honest with you, every single question in the world does have the guidance. So here is the guidance. And here's your answers. Okay, some extra questions just in case you need some extra help. I'll show the answers now. One last one. If you enjoyed that,